let's create a head bob for our character when we are moving. So let's go into Blueprints and create a new folder. This we called Camera Shakes, because we're going to be doing it with a camera shake. Now before we get started, I should advise you that you should know when to use head bobs and when not to. I personally think in quite a lot of games it's a good idea not to use head bobs for your world. In certain horror games, though, I feel like that is a good exception, but it all depends on your story. A head bob will definitely make your world seem more like it's being occupied by a player instead of it being virtual. But at the same time, head bobs can distract from mechanics in the game, specifically if you're trying to be exact. Say like in a first-person shooter, I think you have to be very careful with head bobs, and if you do use them correctly, because like for example, head bobs can make aiming fairly difficult, but a horror game can be a good exception. It all depends what kind of style and what kind of pacing you want your game to have. With that being said, let's get started. So let's go into Camera Shakes, and let's create a camera shake. So go to Blueprint Class, down here, search Camera Shake. We choose Camera Shake right there. And we'll call this CS for Camera Shake. Head Bob Walk. Open that up. Now in here on the right, we just want to open these up real quick. We want to check single instance for camera shake here. We can do that first. And oscillation duration is going to be 0.2. Blend in time and blend out time can stay as default. In our rotation oscillation, open up our pitch. Amplitude is going to be 0.3 and frequency 12. For yaw, we're going to do amplitude 0.3 and frequency 6. For roll, we're going to do amplitude 0.2 and frequency 3. And close rotation. In location, we're only going to mess with the Z, and that'll be 0.6 and 12. And we can close that. And that is everything we're going to do for our walking camera shake. A camera shake legitimately is just messing with how you want your camera to rotate and locate, and just messing with the values how you see fit. These are values I like, and these are values I think look good. So let's duplicate this, and we'll call it run instead of walk. And we can open it up. And there's a few settings, and there's a few settings we need to change. So in pitch for rotation oscillation, this is going to be 0.5 and 17. Yaw is going to be 0.5 and 8. Roll is going to be 0.25 and 5. And for our location, Z, I'm just going to change this to 2 and 17. Everything else can stay the same. We've still checked single instance. Compile and save. And we can close both of them. So let's go into our L1 character. And we're going to make a function. I'm going to call it headbob. In our function, we have to ask if our velocity is greater than our walk speed and we are not falling. So, similar to we did in BPC movement, we can actually copy and paste it if we'd like. We can get our velocity and vector length. And we have to ask if this is greater than our walk speed. So we get our BPC movement and we get our walk speed. Create a branch. Oh. we have to add a AND boolean to this, because we also have to make sure our head doesn't bob while we're falling. So first we're just checking to see if we're sprinting, essentially. And we also have to make sure this velocity is coming from our movement on the ground and not from falling through the air. So we just have to get our character movement, get is falling, and get a not boolean. And my apologies, this is supposed to be a greater than or equal to, not a greater than. So for checking if we are going greater than or equal to our walk speed, and if we are, we then have to ask if we're going greater than or equal to our sprint speed. So we're basically just figuring out if we're walking or if we're sprinting or if we're doing neither. So let's get this vector length and ask greater than or equal to, and we can get our BPC movement again, get our sprint speed, and for safety's measures we can ask if we are not falling again. Is falling, and get a not boolean. So if this is true, we're sprinting, and we need to get the player controller and client play camera shake. Ball off to true, and the shake will be our sprint or our run. And we can duplicate this, because if this is false, it means we are walking, and we will set this to walk, and plug in our controller for target. Lastly, to make it not janky and a bit smoother, for this scale, which is a value of 0 to 1, instead of just having it at 1, we're going to copy this and move these over just a bit, just give us some more room. And we're going to be using what's called a map range clamped. So we'll search for map range clamped, and first we have a value, and then we have 4 floats. And one's the in range A and B, and then the out range A and B. So for in range A and B, it's going to be going from 0 to our max walk speed from a character movement. So for example's sake, let's say this is 400. Now if our outrange A is 0 and our outrange B is 1, this will convert the range of 0 to 400 to 0 and 1. So 200 would output a value of 0.5, and 100 would output a value of 25, 400 would output 1, 0 would output 0. So we can plug in this return value into the scales and compile and save. Back in our event graph, we have to find our move forward and move right, because after both of these, we will be calling our head bob functions. So we can compile and save, and we can now test it out. So when we're staying completely still, so is our camera. And when we walk forward, we have this head bob movement. When we start sprinting, it becomes more intense. We stop sprinting and it goes back to the softer head bob, and we stop moving and it stops. And that is how we add head bobbing into our game.